Hey guys, what's up? Today I'm here with you once again in order to complete another topic related to the hybridization and the structure and shape of the molecule BeCl3. Okay, let's get quickly started with the formula steric number. Remember, we have learned this in so many videos. So for BeCl3, which is 2, 3, it should be half 3 plus 3, which will be equal to, which is plus 0 equals to 3. Now, as soon as the number comes out to be 3, I told you in my previous video that the hybridization is sp2, shape is trigonal, planar, and the bond angle is 120 degrees. This was just a fluke to find out the answer, right? This was a shortcut. Now let me tell you the detailed procedure for the same. Let's get started with the structure BeCl3. So obviously, since I have written hybridization here, so we will be using the valence bond theory and the concept of hybridization to tell the answer. How will I be starting? Okay, this much I know, that BeCl3 boron has to form 3 sigma bonds. 3 single bonds are to be formed, right? So let us start with boron. We know that it is 1s2, 2s2, 2p1, right? Let me represent it as 2s2, 2p1. You know, right? We will never take into account the inner lying electrons. Reasons I have explained, because it is deeply seated close to the nucleus, so more attracted, right? Now, since boron has to form 3 bonds, that means 3 unpaired electrons are required, right? But is boron having 3 unpaired electrons? No, I can see just 1 unpaired electron, right? So boron needs 3 unpaired electrons. So what will happen? There will be excitation. The energy will be obtained from the atmosphere. So this electron goes from 2s to 2p. So when the electron gets excited, we have one 2s1 electron and 2 2p electrons, right? That means now we have a total of 3 unpaired electrons. But before you move forward, that 3 chlorines will come to combine with this. I told you that this is 100% S, because it is S orbital, and these two are 100% P. Right? So these are the characteristics that we have. So this is just 100% orange juice, pineapple juice, apple juice. And if I ask you to combine these 3, so can I say I will have a total of 100% S and I will have a total of 200% P, right? Or let us say 100% S is orange and 2 pineapple juices are there. So we combine all of them. So we have 200 ml of pineapple juice and 100 ml of orange juice, right? So divided. Now we have to form these 3 atomic orbitals. Intermix, combine, mix with each other to form how many hybrid orbitals? They will be forming 3 hybrid orbitals. And the 3 hybrid orbitals will be having 1 electron each, right? But if 100% S is divided among 3 of them, that means each will be getting 33.33% of S. So let me simply write, each will be having percentage S as 33%, okay? And if 200% P is divided among 3, each will be having around 67% P. So each will have 67% P, okay? Now there is no new shape to hybrid orbitals. It's the same thing that we did in initial video. Earlier we had done like this, so this also I'll write like this, okay? 3 hybrid orbital means 1, 2, 3. All the 3 are 33% S and 67% P. So 3 hybrid orbitals are formed. Now the next step is we have to arrange these hybrid orbitals in such a way that they are maximum distance away from each other, right? Now suppose I have 3 markers and I have to arrange them at maximum distance from each other. So this is 180 degree 2. If I arrange like this is 90, this is 90. The angle is 90. If I make them close, obviously I don't want to make them close, I want to make them go away from each other so that repulsions are minimum. So don't you think if I arrange them at an angle of 120 degree, they will be forming the vertices of a triangle, and hence this is the maximum angle at which they can be separated, right? So the same thing I'll do here. I'll put one orbital like this, other orbital like this, and the third orbital like this, and this is boron's atoms, and this is three orbital. These are three orbitals of boron. So each have one electron, and I told you chlorine is 3p5, which is this. So one of the p orbital is unpaired, so each chlorine atom will come with one electron in the p orbital, and hence they will lead to the formation. This is Cl, Cl, Cl. So they will lead to the formation of BeCl3 molecule, where the bond angle is 120 degree. You take a picture, the shape comes out to be trigonal planar, right? And obviously 1s and 2p were combining, so the hybridization is sp2. Understood? See, the results are exactly the same which we obtained from using that steric number formula, but this could be asked as 1, 2 mark or 3 mark question in your exams. So this was the explanation. You need to know the theory for JEE and NEET also, but for shortcut, this much is enough. Okay, so this was all about BeCl3. I will move to the next video now, and you will see how to do the hybridization of methane. Thank you very much. Bye-bye.